In just 3 years, QuickMap has become the world's fastest growing tool for crash and crime scene investigations. QuickMap was designed by LTI with the help of police and professional accident investigators from around the world to make accident and crime scene mapping easier and faster, and also safer. Safer because you can clear a scene in about 1/3 the time it takes with traditional methods, and you're out of the street, out of harm's way, that much quicker. LTI's patented QuickMap system is a complete accident and crime scene mapping system, complete with all the hardware you'll need at the scene, and all the field and office software that you need too. QuickMap software, an HP48 data collector, and a laser from LTI work together to provide a mapping solution that's easy to learn and use. Even better, QuickMap uses training that you've already received. With QuickMap, you'll be mapping accident and crime scenes using traditional baseline offset or range triangulation methods. Only with QuickMap, you do it all electronically and faster than ever before. With QuickMap and LTI lasers, you'll obtain critical distances instantly with the laser rather than measuring them with a tape or a wheel. And you record everything digitally and automatically instead of using a pencil and clipboard. You can do a visual check of all data right in the field for extra confidence, and you can make point-to-point calculations as you gather your evidence. When you're finished at the scene, download your data onto your PC using LTI's DataPAC software. With DataPAC, you can generate a point list, as well as verify all raw data. You can view a point feature map, and even take your file into your preferred CAD program to create a scale drawing, complete with traffic and vehicle symbols. We will also show you a new method of mapping that makes mapping in even the toughest situations fast, easy, and accurate. But no matter which method you choose, in the end you will have the data to create a diagram of the scene that is accurate, to scale, and professional. Listen to what this officer had to say about QuickMap.
I'm Detective Mark Davis with the Dayton, Ohio Police Department, and I've spent the past 18 years as a member of our department's Fatal Accident Investigation Unit. We first began using QuickMap back in 1994 when it was introduced. At that time, we were just using a clipboard and a roll of tape, and we would probably average 20 to 30 points in any given diagram. Since switching over to QuickMap, we now average between 60 and 100 points per diagram, and we end up with a much more detailed and accurate drawing. QuickMap is very easy to learn, very easy to use, and it affords us the accuracy that we need in drawing professional-looking diagrams.
Gather the critical information quickly, clear the accident scene quickly, and do it accurately and safely, and make it easy to use. These were our goals as we worked with police accident investigators to create QuickMap, and it has become the system of choice for over 100 agencies worldwide. Agencies such as the North Carolina State Patrol, Indiana State Police, Colorado State Police, Boston Police Department, Natick, Massachusetts Police, Dayton, Ohio Police, the Italian Federal Highway Police, Sussex County Police in the United Kingdom, and many more. QuickMap is easy to learn and use, but powerful enough for any professional accident investigator. However, there is no need for weeks of surveying courses, like with some other systems. But like anything, a little practice helps. You should practice mapping a few mock scenes before going to an actual crash. Although this video does not follow the manual exactly, you should read the user's manual provided to help make yourself familiar with the system. This video provides an introduction to QuickMap 3D. It will get you familiar with the system, but it does not cover every option and tool in the system. After watching this video, reading the manual, and mapping a few scenes, you will be able to create a professional scale map of your scene that you can bring into any courtroom. Here is the outline that we will follow. First, we will begin by going over the equipment supplied with your QuickMap system. Then we will get the field data collector and your laser configured for mapping with QuickMap. Then we will map in evidence points using 3 different methods. As we map, we will show you how to describe your points, and then we will do a visual check of all the data collected right in the field. We will then return to the office to download the data into your PC using LTI's DataPAC software. We will examine all the tools available in DataPAC and also create a DXF file for exporting into your CAD program of choice. On your PC, we will show you how to display and print a point list, view a point feature map with lines and annotations, and also show you how to verify your raw data that you downloaded from your data collector. You will also be able to measure distances between points and vehicles, as well as make dimension lines and create notes on your map. We will also briefly discuss the crash zone, an accident and crime scene drawing program designed specifically for you. This video assumes a basic understanding of accident or crime scene mapping. It also assumes a basic understanding of how to operate either an LTI impulse or ultralight laser. However, because of the many different CAD programs that are available, this video will not go into CAD program instruction. Let's start by quickly examining each component in the system. LTI offers a complete package for crime and accident scene mapping. All the equipment you will need fits perfectly inside one case. And with LTI's new Rugged Accident Investigator case, you can custom design your own interior compartments to include any other equipment that you have. Every QuickMap AI package comes equipped with 2 tripods for mounting your reflective targets. These tripods are used to support your targets. 2 reflective targets are provided in each kit. These targets are highly reflective and provide the highest degree of accuracy when mapping. We have also included 2 strobes for better visibility of your targets at night. The QuickMap 3D AI kit also includes an HP48 environmental hard case and hard case bracket. These provide a convenient mount for your data collection device and offer shock protection for your data in the field. The case is also completely waterproof. The HP48 environmental hard case bracket is supplied with every HP48 hard case. This bracket allows you to mount the hard case to the staff quickly and securely. LTI's staff and bipod legs provide stability to equipment in the field to ensure that your mapping is accurate. Just place the staff on the point you wish to map in. Quickly level your instrument using the bipod legs and begin mapping. LTI's Quick Disconnect feature allows the user to quickly break down and store your equipment when you are finished mapping in the field. The Field Sherpa is furnished with all professional packages. The Field Sherpa is a heavy-duty carrying bag that conveniently stores and transports your staff, bipod legs, and much more. 2 cables are provided with your QuickMap system. The first is an LTI 4-pin to DB9 download cable for connecting the laser to the HP48 hard case. The second is the DB9 serial cable that allows you to download from the hard case directly to the PC. And we provide a small light for mapping at night. As we said, your QuickMap system comes with 2 tripods. Remove these tripods from the case and extend them to their maximum height. After setting up your tripods, attach your reflective targets on top of the tripod. The result should look like this. You have just assembled 2 excellent control points for mapping your accident scene. The next step is assembling your laser positioning system, or LPS. First, attach the bipod legs to your staff. To do this, slide the staff through the loop at the top of the bipod legs and stabilize both parts by turning the clamp on the bipod legs until it firmly grips the staff. Next, attach the data collector bracket and the base the same way. Using the 4 Phillips head screws provided, attach the HP48 environmental hard case bracket to the staff base plate. Reconnect the base plate to the staff with the hard case bracket attached. After reconnecting the base plate, attach the HP48 environmental hard case to the hard case bracket with the 4 thumb screws provided. As you can see, your data recorder is conveniently mounted to your staff for mapping, yet easily detached when necessary. Now you're ready to mount your impulse or ultralight unit. Every QuickMap 3D package is supplied with a laser yoke. This yoke allows you to mount your laser to the stability kit. Notice that the top of your impulse staff has a 5/8 thread and your laser yoke has a 1/4-20 thread. In order to attach the laser yoke to the staff, we've provided a 5/8 to 1/4-20 brass adapter with your QuickMap package. Attach the 5/8 to 1/4-20 adapter to the top of the staff. Your staff now has a 1/4-20 thread on which the laser yoke can be mounted. If you have not already done so, attach the appropriate mounting plate assembly to your laser. The mounting plate assembly is attached to either the left or right side of your instrument. Drawings that show you how to attach your yoke mount are in your laser user's manual. The next step is attaching your laser to the yoke. Then attach the cable to the laser and the hard case, and you're ready to map. Your QuickMap software package consists of the QuickMap 3D software card, QuickMap 3D manual, data collector overlay, and DataPAC 3D. First, ensure that your HP48 is powered down. Remove the protective cover and insert your QuickMap 3D software card into slot 1 of the HP48 data collector. Slot 1 is the slot that is closer to the screen of the HP48, not closer to the back panel of the HP. When your card is in place, replace the protective cover. Next, place the QuickMap overlay over the HP48 keyboard. Insert the HP48 into the hard case and attach the cable to the HP48, being sure not to bend the pins on the data collector. QuickMap 3D can be used with the ultralight or impulse laser using the appropriate interface cable. To successfully interface the HP48 to the impulse laser, your laser must be downloading in Criterion 400 format and be set to Auto Download. See your impulse user's manual for instructions on choosing a data string format and setting your impulse to Auto Download. To successfully interface the HP48 to your ultralight laser, your ultralight must be in Criterion 2020 format and in survey mode. Please see your ultralight user's guide for instructions on changing this setting. These are settings in the system menu of your impulse and ultralight. Once you set them, they will stay that way until you change them. There is no need to set them each time, and if your settings are not correct, QuickMap will recognize this and display an error message. In this section, we will go through the steps of how to map in points using 3 different methods. The first 2 methods should be very familiar: baseline offset and range triangulation. The third method, Radial with Azimuth, uses a new technology that makes mapping in even the toughest situation fast, easy, and accurate. When using baseline offset mapping, you will establish a baseline that runs the length of the accident scene. To map in points, you will travel along that line and take shots first to your origin and then to your evidence at 90-degree angle offsets from that line. Using QuickMap in the field is easy. It's primarily a menu-driven system, which means that to a large extent, the program anticipates what you need and prompts you for that specific information. If you have followed all of the steps up until now, then you are ready to run QuickMap 3D. Turn the HP48 on by pressing the On key in the lower left-hand corner. Press the right Shift key and then press the 2 key. You will see the letters QM3D above the A key on the screen. Press the A key, the key in the top left-hand corner, to initiate the program. You will see the words Start, Lang, and About above the A, B, and C keys, respectively. Don't press any buttons yet, but the A key under the word Start will start the program. The B key under the word Lang will allow you to choose between several foreign languages. And the C key under the word About will show you the version of QuickMap that you are using. Press the A key to begin the program. You should see the main menu with 4 options. New to create a new file, Old to open an existing file, Delete to delete a file that is on your HP, and End to end the program. Again, wait to press any buttons, but notice that these options listed along the left edge of the screen also correspond with the keys at the top of the keyboard. The word New corresponds to the A key. The word Old corresponds to the B key, and so on. The keys at the top of the keyboard that correspond to the words at the bottom of the screen are called action keys. From here out, we will refer to these keys with the action that they invoke. For example, in this menu, instead of saying press the A key, we will say press the New key. Press the A key, or the New key. As you can see, QuickMap is now asking you to give your new file a name. Also notice that there is an alpha symbol at the top of the screen. This symbol indicates that the keys on the HP48 have now become an alphanumeric keyboard. Each key on the HP48 has a letter next to it, and you can use those to create your file name. You can use numbers or letters, or a combination of both, to name your file. Let's name this file A Street. Use the SPC key at the bottom of the screen to put a space between A and Street. Press the Enter key when you are finished naming your file. You should now be in the New File Options menu. This menu allows you to set up the options that will dictate your mapping for this file. Notice that under the survey method, Range Triangulation is highlighted. Highlighted items indicate the option that you are currently selecting. Press the Choose key, and then use the arrow keys to highlight Baseline Offset. The arrow keys are the keys with the triangles that point left, right, up, and down. When you have highlighted Baseline Offset, press the OK key. As a quicker option, you can also use the plus-minus key next to the Enter key to toggle the survey option to the next method. Try this now. Press the plus-minus key until you see the words Baseline Offset in the highlighted area. Since we are using Baseline Offset for this first map, this is what the screen should read. Once you have chosen your mapping method, you will need to choose the units with which you will map. To do so, use the arrow keys again to toggle down to the Units line in the New File Options menu. Again, use the Choose Command key or the plus-minus key to toggle between feet and meters. Follow this same procedure to choose between degrees and grads. Here in the United States, we use degrees as our units of measurement for a circle. If you are using an impulse, be sure that the unit setting on the impulse matches with those you are choosing here. If you are using a marksman, use the check key to place a check mark next to the marksman. Do not place a check next to the Z value option. We will not be discussing mapping in 3D at this time. When you have set all of the options to your liking, press the OK key. You are now at the Origin Values screen. Simply put, you must assign coordinate values to your origin. In a baseline offset map, the origin is the point that all other points will be based on. Usually 0 for both the X and Y will work fine. This same screen also asks for your baseline azimuth, or the direction that your baseline runs. If you have a compass handy, you can enter in the actual azimuth value. If you don't have a compass, then the default value of 90 will work fine. Once you have established your origin point and baseline azimuth, press the OK key. After you press OK, a screen reminds you to denote whether points are on the left or right of your baseline as you are mapping. You can press any key to continue. You are now ready to map in your first point. As you can see, the screen is ready to take two measurements, one to the origin and one to the feature or evidence point that you want to map. Position yourself on the baseline at 90 degrees from the point that you want to map. Point the laser at the origin and press the fire button. or squeeze the trigger depending on the model laser you have. You should hear two beeps, one from the laser and one from the data collector. Check to see that the distance displayed on the impulse or ultralight is the same as the distance that is displayed on the HP. Remember that if you are mapping with an impulse, you should be in HD or horizontal distance mode for mapping. After you are satisfied with the distance shot to the origin, turn exactly 90 degrees and aim at the evidence point, and then fire the laser again. You can again check the value displayed on the laser against that on the HP. They should be the same. If you are satisfied with your measurements, then check to make sure that the left-right designator agrees with the position of the feature. That is, when you are facing the origin, is your feature on the left or on the right? Change the designator on the HP by pressing the A key to toggle between left and right. You can do this at any time while you are collecting measurement data, but you must check it for each point. Once you are satisfied with the measurements and you have chosen left or right, save your measurement. To save your measurements, press the Store Command key. Now that you have calculated and stored your first point, you must describe that point. QuickMap allows you to describe your points in one of several ways. You can describe the point as part of a line, for example, the beginning or end of a skid mark. Or you can describe the point as one corner of a vehicle in your scene. You can also describe your point as part of a polygon. Perhaps you have to map in a concrete island in a roadway. For now, let's just describe the point as a feature, like a tree or a sign or a corner. Press the Feet key. Now enter your specific description. Let's call this a tree. Notice again that the alpha symbol has appeared at the top of the screen. When you have finished, press Enter. In a moment, we will show you how to turn this feature off if you would rather not describe each point that you map. You are ready to map your next point. Move yourself along the baseline again until you are perpendicular to the next evidence point. First, shoot to the origin and check the values. Then shoot to the feature that you want to map. Check that value and then make sure that the left-right designator is correct. And then press Store to save your point. What happens if you are not satisfied with a measurement that you see on the screen? Simply push the up or down arrow to highlight the measurement that you wish to change and reshoot the point. The new distance information will replace the old one. Let's review some of the basic principles of baseline offset mapping. Always locate yourself at a point on the baseline directly across from the feature. Each feature requires two shots. First measure to the origin, then to the feature. Specify right or left orientation. Store the point data. Then classify your point and describe it. You should have 3 points on your map if you have been following along. To take a quick look to confirm that they are correctly located, press the Results key, the S key just above the Enter key. You should see your 3 points on the screen, the origin and the 2 points that you mapped. You can see that the origin is marked with an X, and the other 2 are simply dots. When you are ready to continue mapping, press the Resume key, and then Enter. You are now ready to map in the next point. Continue mapping in points in this same manner. When you are finished, just turn the HP off by pressing the green Shift button, and then the On button. Your file is saved. You can add points to it later, or you can download the file to your PC. Should you want to reopen this same file later on, simply choose the Open Old File option from the main menu. You can always access the main menu by pressing Right Shift and then Enter. Remember that the Right Shift button is the green button just above the On key. Before we continue with mapping methods, let's cover a few of the options that are available. Press the Options button, the O button, or the button that has the word Eval on it. This accesses QuickMap's option menu. Notice that there are several items that can be checked or not checked, depending on what options you would like to activate. Notice that there is the word Store. If you check this option, then you will be asked to describe each point as you map them. If you do not check this option, then each point will only be numbered. There is also the word Last. If you check this option, the last description that you used will automatically appear for the next point. This can be handy if you are mapping several points that will be described the same way, like edges of pavement. Another option is the Classify option. This option allows you to denote each point as part of a line, part of a polygon, part of a vehicle, or simply as a point. These classifications will be downloaded into DataPAC and can be used to create a very simple map right in DataPAC. If you are going to create your final map in a CAD program like Crash Zone or AutoSketch, then we recommend that you do not use this option. If you are going to create a very simple map using only DataPAC to create your drawing, then this option can be very useful. When we examine downloading and using DataPAC, this will become quite clear. For now, let's deactivate this option. You can access the Options menu anytime you have a file open. In this section, we will show you how to map in points using the range triangulation method. You will remember from your training that when mapping a scene using the range triangulation method, that you are going to set up two control points and take measurements from both to calculate a position. Although this method is unpractical when using a tape or wheel because of the higher order of mathematics involved, we have found that this is the most popular method of mapping when using QuickMap. This is because a user occupies each point that he or she wants to map, then quickly takes shots with the laser to each control point, and QuickMap does the rest. It's that easy. Let's begin. From time to time, your data collector turns itself off to save energy. Simply turn it on again by pressing the On key. From the New File Options menu, press the New button to create a new file. Enter your file name using the keyboard. Let's call this file RT1. You are now at the New File Options menu, as you have seen before. Because these are the most common settings, QuickMap 3D defaults to range triangulation, feet, and degrees, and does not have marksman or Z values checked. Therefore, you should be able to press OK and move on. Before you can begin mapping points, you must set up two control points. This screen allows you to define your first control point. Unless you have known points, use 0 and 0 as the X and Y values of your first control point. Press OK. The next screen asks you how you would like to define your second control point. You can set your second control point using two different methods, with X and Y coordinates, or by using a distance and an azimuth. Either way, you will need an exact distance between control point 1 and control point 2. Choose one of the two methods, and then use the laser to shoot the distance between CP1 and CP2. If you have a compass, enter the azimuth and distance. If you don't, then just enter the distance in the X field and a 0 in the Y field. Press OK when you are satisfied with the coordinates. After you set the coordinates for your two control points, you are reminded to designate whether points are on the left or on the right when facing CP1 from 2. Note that this is a designation of left and right when facing CP1 from CP2. Press OK, and you are ready to map. As you are mapping, you can see the left or right designation near the top of the screen. Just like with baseline offset, the left or right designator can be changed at any time while you are collecting data for a point. However, you must check it for each point to make sure it is correct. To map in an evidence point, you will occupy the points that you want to map. Place the LTI staff directly over the point you wish to map in. and level the staff. Take a shot to your first control point and verify that what is on the laser has come through to the data collector. Remain on that same point, pivot the staff, and then take a shot to the second control point. Remember that you can use the arrow keys to move the cursor up or down to highlight one of your measurements and reshoot it if you are not satisfied with your first shot. Once you are satisfied with your two distances, check to see that the left or right designator is correct. That is the feature on the left or right when facing control point 1 from control point 2. Press the A key to toggle between left and right. Before we store the point and leave this screen, take note that the two control points are labeled as 1 and 2. This means that the first 2 points created are your current control points. You may change either one or both of your control points at any time. Any point that you have mapped can become a control point. We will examine this in depth a bit later. Press Store if you are satisfied with the measurements to the control points. You will remember that after you store a point, you now need to classify it and then describe it if you have these options activated. For now, let's again call this simply a feature and then use the keyboard to describe the point as a stop sign. After you describe your feature, press Enter. You are now ready to map in another point. Let's review the steps in mapping a point using range triangulation. Use the same procedure of occupying the point that you want to map. Take shots to both control points. Verify that your left or right designator is correct and use the A key to change it if necessary. Store the point, classify it, and then describe it. At any time, you can use the Results key to see the points you have mapped on the screen. From the point display, press Resume and then Enter to continue mapping. Before we move on, it's important to discuss the placement of control points when mapping using range triangulation. Try to choose your control points so that you can see most of the features from both points. And for optimum mapping, use what we call the peanut diagram as you place your control points. Map in the shaded green area and avoid mapping outside this area. Also, note that features in between or in line with the two control points are very difficult or impossible to map as shown. Change control points to map points in this area. For features that are farther than 3 times the distance between the control points, you should also change control points. For example, if your control points are 100 feet apart, your features should not be more than 300 feet away. There are 3 instances that produce error messages in range triangulation. They are geometry warning, no intersection, and coincidental point. Geometry warning means that the data point you are trying to map falls into the invalid area and presents a possible error. You can choose to store the point anyway, but it is best to reshoot it because QuickMap has recognized that there is the potential for some error to be introduced when calculating the exact position of this point. No intersection means the distances to the control points or feature do not geometrically form a triangle. Reshoot your point, making sure you have clear line of sight to your control points and have them defined correctly. Also be sure that you have entered the correct distance between the two control points. Coincidental point means both control points have the same coordinates. On the data screen, you will be able to see that both CP1 and CP2 reference, for example, point 4. When you see this error, redefine one of your control points. As we said earlier, you may have the need to change control points while mapping a scene. This could be because you are mapping a very large scene, or because you cannot see both control points from the point you want to map. Changing control points is easy. You can redefine control points one of 3 ways. You can enter known coordinates, enter an azimuth and distance, or you can assign an existing point as a new control point. The easiest, most convenient way to redefine control points is to use a point that you have already mapped as a new control point. You can assign any existing point as a new control point, 1 or 2. First, decide which of the points that you have already mapped that you would like to become your new control point. From the data screen, press New 1 or New 2, depending on which control point you would like to change. For our example, we will use an existing point as a new control point. So press the Point Number button. The next screen prompts you to enter the number that you would like to use. Press OK after you enter the number of the point for your new control point. Let's choose point 3 as our new control point 1. Enter the number 3 into the field and press OK. As you can see, the data screen has been updated to reflect the change. You are ready to map the next point using point 3 as control point 1 and your original control point 2. You can change control points as often as you would like, and you can always return to using your original control points as well. Just change them using the same method as we have described. Now let's review the important steps for mapping data points using range triangulation. First, choose your control points carefully. The range to features should not exceed 3 times the distance between control points. Avoid mapping features in between or in line with the control points. Remember, each data point requires 2 measurements, one from the feature to control point 1 and one from the feature to control point 2. And finally, specify within QuickMap whether the data point is to the right or left of the control points as you stand at control point 2, facing control point 1. Then classify your point and describe it if you have these options activated. Radial with Azimuth Mapping requires that you have an LTI angle encoder, along with your impulse or your ultralight. Contact your LTI representative for a demonstration if you don't already have an angle encoder. We will not go into a detailed discussion of the angle encoder's operation in this video. We will only discuss what is necessary to map an accident or crime scene with the angle encoder. Mapping with an angle encoder using the Radial with Azimuth method can make mapping in even the toughest scenes quick and easy. You still take shots with the laser to map points, but you take just 1 shot per point, not 2, to either the evidence or to a target that a partner holds. This is because while the laser measures the distance, the angle encoder calculates the exact direction of your shot. Before you begin, you must set up your angle encoder for use with QuickMap. All that is involved is setting your angle encoder to deliver the proper string, the CR400 string, and to download that string in auto mode. That is, to download the information automatically when the laser is fired. These are the factory defaults, so there may be no need to alter these settings. But it is good to become familiar with how this is done. See your angle encoder manual for information on how to set these choices. As we said, mapping using the Radial with Azimuth method is done by taking 1 shot with your laser to either the point that you wish to map or to a target that your partner is holding. The laser measures the distance, and the angle encoder measures your direction or horizontal angle. You take these shots from 1 or more control points at each scene. From the control points that you choose, you should be able to map in several of the points in the scene. Begin by using the same button presses as before. If the data collector is off and the program is not running, press On, then right shift, and then 2. You will see the letters QM3D above the A key. Press the A key and then press Start, the A key again. From the new File Options menu, use the Choose and Arrow keys, or the plus/minus key, to change the surveying option to Radial with Azimuth. Then set your origin values. As we've said before, you can enter known coordinates, or 0 and 0 will always work fine. As we said a moment ago, the origin point should be a position that allows you to see many of the points that you want to map. Here is an example of where you might set up the origin point in this scene. If you cannot see every feature from your original origin point, you can redefine your origin and move there to map in the remainder of your points. After creating a Radial with Azimuth file and establishing your origin point, you are ready to start collecting data. You will notice that QuickMap 3D is prompting you for a distance and an azimuth reading. All of this data is collected and downloaded automatically when you fire the laser. From the origin, aim at the first evidence point, or to the target that your partner is holding. Fire the laser, and you will see that all of the information is downloaded to the HP-48. If you are satisfied with the data, press the side button on the HP. The side button calculates and stores the point information and moves you to the next screen to classify and describe your point. You will remember how to do this from previous sections. Be sure that the word "for" is above the A key when mapping using Radial with Azimuth. This indicates that you are taking shots from the origin and not back to it. If the word "back" is above the A key, simply press the A key to toggle it to read "for." You will never be taking shots to the origin to map in points using the angle encoder. If you cannot see every feature from the origin, you will need to redefine your origin point. To do this, shoot to the point that will be your new origin and press the Trav key. The Trav key stores the point, but it also tells QuickMap that you wish to place yourself on that point to continue mapping. Once you are at the new control point, you will need to reorient the angle encoder so that it is reading the correct angle from that point. To do this, obtain the complementary angle of the shot that you took to the new CP. The angle encoder has this angle stored. You just need to recall it. Press the Comp button on the encoder to bring up this angle, and then press the same button again to set this new reference angle while you are aiming at your first control point. You can now continue mapping in the same fashion. See your MapStar Angle Encoder manual for a more complete explanation. You can do a visual check of the points that you have mapped in by pressing the Results key at any time. QuickMap has several onboard tools that allow you to examine and edit and add to your data. This section details those onboard features. Some of these tools are reached through QuickMap's Utilities menu. Once you have a file open, from any of the mapping screens, press the U button to access the Utilities menu. Let's look at these in the order that they appear. The first is Point Recall. This feature lets you review, edit, and delete point data that has been stored in a file. If you have points already in the file, you can press the Point Recall button. The top line of the display screen tells you which data point you are viewing and the total number of points in the file. There are 6 options within Point Recall. The Raw button allows you to view the raw measurement data for a point. The Delete button deletes a point. You cannot delete all points, only those that are not control points. Edit allows you to edit the text note, classification, left-right designation, instrument height, and target height. You can change the coordinates of your origin or first control point and shift all subsequent data points relative to the new coordinates. Go To allows you to view a specific data point in the file. Prev scrolls you to an earlier data point in the file. Next scrolls you to a later data point in the file. To exit the Point Recall menu, press Resume, then press Enter. The next option in the Utilities menu is the Download function. Use this to download your files to DataPAC that runs on your PC. We will use this function in the next section. The third option is the Plot function. This is the same as using the Results key. It allows you to see the points that you have collected on the screen of the HP-48. To exit the plot screen, just push Resume and then Enter to continue mapping. The last 3 options have to do with creating and manipulating a pick list. A pick list is a list of user-defined descriptors that you create on the PC in DataPAC. You can use this list to describe points instead of using the HP keyboard every time. You can create multiple lists and save them on the PC and upload and download them for use later. For detailed instructions on creating and using a pick list, see the QuickMap User's Manual. There are a few other items that you will want to become familiar with that are not accessed through the Utilities menu. QuickMap 3D can calculate the distance between any 2 points in a data file. To view the distance between 2 points, press the point-to-point hotkey from an open file data input screen. This is the key that has the 1 over the X on it. Once you are in the distance between points screen, enter the 2 points you want to analyze using the numbers on the keyboard and the OK key. Then use the Calc key to calculate the data. You can see all relevant information regarding those 2 points on the screen. To exit this feature, press Resume and then Enter. Rather than storing completed data files on the HP 48, we recommend that you transfer your files to DataPAC 3D. Once a file has been transferred, it can be safely deleted from the HP 48. This will help free up data collector memory and keep your HP 48 running efficiently. From the main menu, you can press the Delete button to delete files. Scroll to the desired file using the arrow keys, and then press OK. QuickMap gives you an extra warning to allow you to make sure you want to delete the files so that you don't delete them by accident. There is a note taker function that allows you to enter descriptive notes about the scene that you are mapping. From any of the input screens, press the N button on the keyboard, and you will be prompted to enter notes about the scene. Use the keyboard to enter any notes you would like. These notes will then be downloaded to the computer when you download your file. There is also a memory key that you can access to display the amount of remaining memory in the HP 48. Simply press and hold the J key at any time to display remaining memory. Should you forget any of the hotkeys that we have mentioned, you can press and hold the H button or the Help button at any time to display all of the hotkeys and the functions that they provide. In this section, we will discuss the DataPAC Office software that comes with QuickMap 3D. DataPAC Office software is a versatile post-processing program custom designed for QuickMap 3D file download and analysis. We will learn how to download files from the HP 48, view the raw data, view a point list, view a plot of the points, and use DataPAC 3D's map-making aids. We will also convert files to DXF format for use in CAD-based programs. To transfer a file from QuickMap 3D to DataPAC, connect your HP 48 to your PC using the HP 48 to DB9 download cable supplied with your AI package. Next, run QuickMap and DataPAC and access their respective download utilities. To do this in DataPAC, click on the small button that has a lightning symbol on it. Or you can select Download from the File pull-down menu. The Download dialog box will appear on the screen. Ensure that the appropriate serial port is specified, for example, COM1 or COM2, and then click the Start button. On the HP 48, open the file that you want to download. Then press the Utilities hotkey. From the Utilities menu, press Download or Down on the HP 48 to begin transferring files from the HP to your PC. When the download is complete, DataPAC will display a Download Complete message. Click OK. All your data points will appear on the screen. DataPAC will prompt you to save the file immediately. You must save the file to enable all of DataPAC's features. After saving the file, all of the DataPAC mapping features are available to assist you in analyzing your data. There are 5 tabs within DataPAC: Raw Text, XYZ Text, XY Map, XZ Map, and YZ Map. The first tab is Raw Text. Raw text lets you review all the data in a file. These include all of the measurements that you shot with the laser, the survey method that you used, the measurement units, the calculated x, y, and z coordinates, the control points that were used for each point, the notes that you entered, and the description that you gave to each point. For file security reasons, you cannot edit the raw text in DataPAC. It will always be preserved as originally downloaded. The next tab is XYZ Text tab. XYZ Text shows a numbered list of the points, their coordinate data, along with the notes that you have used to describe each point. These are all editable, and you can add any comments that you would like on this tab. You can save this view as a text file by clicking the Save As function under the File menu and using a text file extension. The Map X versus Y tab plots your data points along the X and Y axis to give an aerial view of the accident scene. The Map X versus Z tab plots your data points along the X and Z axis to illustrate the change in elevation along the X axis. The Map Y versus Z tab plots your data points along the Y and Z axis to illustrate the change in elevation along the Y axis. In order to use the Y versus Z and X versus Z tabs, you must be collecting Z values when you mapped in your scene. It is recommended that you create a map in the field with the intent of examining the data in this way. Many times, accident investigators using QuickMap will create a second map that is used specifically for this purpose. This is because your normal map will contain too many points to enable a clear view of the cross-section of an accident, including the Z value. DataPAC has a variety of map viewing aids to show and hide features on your map. You can access these by right-clicking on the screen as a shortcut to the View menu. These viewing aids consist of large point symbols, point descriptors, draw dimension, draw line features, draw polygon features, draw polygon name, draw vehicles, and show point numbers. You can click these on or off as you like. DataPAC is also equipped with a few other analysis and customization tools. These include annotation insertion. You can click on the A button at the top of the screen, and then click again somewhere on your map in this view to add words or comments on your map. Measure distance. This allows you to measure the distance between any 2 points on the screen. Draw dimension lines. This feature allows you to add distance lines onto the map in X versus Y view. Erase. You can erase such annotative lines or comments with this button. Area. You can measure the area of a certain section of your map using this feature. Slope. The Slope button allows you to calculate the percent slope between 2 points. Zoom in and out functions. These buttons allow you to get a closer look at a certain section of the map by zooming in or out. For more detailed descriptions of DataPAC's 3D functions and features, please see the QuickMap User's Manual. To work with your map in a CAD program to create a drawing of your map, you will need to convert the map into DXF format. To create a DXF formatted file, put your view into the X versus Y tab. Then click the DXF icon on the toolbar to display the Convert Map dialog box. You will need to specify the following output parameters. File name. The upper box displays the default file path of the DXF and the file name. If you would like to save it to a different directory, press Browse. Pay attention to the file path. This will be important when opening the file inside your CAD program. There are a few other options that you may change when you create a DXF file. Text size. If your file contains points that are close together, you may want to select the small text size. Text offset. The setting determines the distance between text and its corresponding point. Output layers. Select the output options that you would like to transfer to your DXF file. These are similar options to those that you view in the Program Map tabs. You may also rename the layers. Converts points. If you would like to export some but not all of your data points, enter the point range in the selection boxes. If you do this, you will not be able to export the line, polygon, or vehicle layers. After specifying all of your export parameters, click OK to finish. You are now ready to open your file from your CAD program. To work with your data points in the Crash Zone CAD program, you should not create a DXF file. You simply need to use the Crash Zone's Open command to open the raw file that you have saved in DataPAC. The Crash Zone reads in all the data directly from DataPAC's raw file. Once you have opened the raw file created with QuickMap, simply use the Crash Zone as you normally would. See the Crash Zone User's Manual for complete instructions on the Crash Zone. This video has introduced you to mapping accident and crime scenes with a laser from LTI and our patented QuickMap system. While we have covered the basics, we have not covered all of the capabilities that QuickMap offers. It is important that you read your manual thoroughly to make yourself familiar with all of the features that QuickMap includes. There are features like mapping in 3D and creating specific classifications that allow you to create lines and symbols in DataPAC that we have not covered in this introductory video. You will want to use some of these features and others you will not. QuickMap is flexible enough to allow you to configure the system to operate exactly the way you want it to. You may want to use these options later when you are more comfortable with the system. It's up to you. However, there is no substitute for going out in the field and mapping just a few mock accident scenes to get you ready for the real thing. QuickMap will make your job easier and allow you to map faster and safer than with traditional methods. And in the end, you'll be able to create professional scale diagrams that you can present in any courtroom. QuickMap 3D, the world's fastest growing tool for crash and crime scene investigation.